So today we have Pushkar Kulkarni with us. Is currently working at Canonical. He plays with the Java runtime systems, works with the OpenJDK, is part of the Java mission. So I will not waste much of your time and just let him carry it forward from here. So
yeah, thanks Arun. So I realize some of you are here after attending Abram's funeral. So thanks for being there and thanks for being here after that. So my name is Pushkar Kulkarni. Vladimir couldn't be here to the conference, so I'm going to do this talk on Java and FIPS. You might be wondering what a Java and FIPS talk is doing in a Debian conference. Sadly, you'll have to wait for the last slide. This is more of BOF material. This is more of a brain dump, this entire slide deck. So let me start with a show of hands. So how many of you write Java code for a living?
Not a living, but
okay, and how many of you work with cryptography modules, either Java or outside of Java? Okay, so it's going to be more of an education session, I guess. But why this is happening in a Debian conference, you'll have to wait for the last slide for that. So I am an infant in the Debian universe. I like this term universe. I first read this in a blog post a long time ago where the word universe was used instead of ecosystem. So the author of the blog was like, we have various universes. We have the Apple universe, we have the Google universe. So this is the Debian universe. So I'm pretty young here. I've just joined Canonical 3 months ago. I've been working on Java runtimes, both proprietary and OpenJDK, for a long time now. I have contributions stretching right back to Java 1.3 and even to the headstream today. I started off with the JIT compiler and then later moved to Java standard libraries. In between, I also contributed to the porting of the Swift language to Ubuntu. So I was a committer there. My participation gradually fizzled out of that. But yes, I spent around 3 to 4 years bringing up what we call the server-side Swift ecosystem. So I'll try my best to not express opinions here, but if I do express, those are my own. So that's just a disclaimer. So let's start. So what is FIPS? So FIPS is short for Federal Information Processing Standard. So in short, if you are selling any kind of hardware or software that does cryptographic calculations, it uses cryptography algorithms, and you want to sell that to a US federal agency, you need to get FIPS certification. So FIPS certification is given under a program called CMVP. I think it's a joint venture of the NIST from US and there's another agency in Canada whose name I can't remember right now. Yeah, it's there, Canadian Center for Cybersecurity. So under this program, companies, or I should say organizations, apply for FIPS certification, and only when you have certified all your cryptography modules under FIPS, only then can you sell them to a US federal agency. So the two known certifications currently are 140-2 and 140-3. I was hoping to switch between the slides and the website, but I'm not able to get my screen mirrored here. So this is just an external display. Okay, so what is FIPS certification? It is granted by NIST, which is short for National Institute of Standards and Technology. That's an American entity. So in short, a FIPS certified module will permit only FIPS approved cryptography algorithms. So there's an example here. So if you ask for the advanced encryption standard algorithm with key sizes which are given there, those are FIPS approved. So the module will let you use that algorithm. Whereas there are other algorithms like the ones which are listed here, Blowfish, Camellia, Chacha 20. So if you ask for them, the module will reject them. Yeah, so that's what the last point says. A FIPS certified module will not permit algorithms which are not FIPS approved. Now, it covers most of the cryptography functions, starting from deterministic random bit generators, ciphers, key agreement, transport stores, MAC, message digests, signatures. And I think there are dedicated documents on each of these which are not really easy to understand unless you're a cryptographer. So they are really terse, not really easy to understand. And the certification is not also simple like just a test suite which can be run, and if that passes, you're certified. I don't think it's that simple. I don't think it's open sourced as well. I mean, NIST does not tell how they certify modules, and I also think it takes a while. It's not something that happens quickly. So, what is FIPS certified? So, the best example is most of the native cryptography modules like OpenSSL or NSS. These have FIPS certification. Now, I will upload the slides later, but you can visit that website which is quoted down there, and you can actually search for modules which are FIPS certified. An example would be, so I just searched with the vendor name Canonical and the module name OpenSSL, and you can see that there are 5 OpenSSL modules, one for, there are different releases. So we have one for 16, we have, I don't know why we have 2 for 18, maybe one has expired, and then we have 2 for 20. So OpenSSL has 5 certifications just from Canonical, and if you search for OpenSSL only without the organization name, you will find that there are 47 FIPS certified OpenSSL modules. The point I'm trying to make here is that source code is not FIPS certified. It is the binary, the module that is FIPS certified. So if an organization wants to claim FIPS certification of OpenSSL on their operating system, they need to go and seek this FIPS certification. So you'll have FIPS certified OpenSSL from Red Hat, from Canonical, maybe from Windows, and so on, even the other proprietary operating systems. So this is a very important point here, that it's the binaries that are certified under FIPS. Now so there is now a difference between certification and compliance. So certification, FIPS certified is something that is certified by, which is stamped by FIPS, whereas FIPS compliant is something that uses a FIPS certified module. It may not be, and that particular module may not be entirely FIPS certified, but because it's using only FIPS certified cryptographic modules, we call it FIPS compliant. So an application that uses only FIPS certified cryptography binaries is going to be FIPS compliant. We're going to call it FIPS compliant. Now, what is so special about Java? So here we segue into Java. So Java has something called actually I should first probably, okay, I'll talk about this slide first maybe. Or maybe I'll just continue with this. So Java has something called the Java Cryptography Architecture, which includes something called the Java Cryptography Extensions. Now you can write security providers, which are modules maybe written in Java or Java and C++ both. You can write security providers using the Java Cryptography Extensions interface, and you can configure them using what we call the java.security file. So I'm not going to go into the depth of that because this itself is subject of a long tutorial. So yeah, but the point here is Java allows you to write what we call security providers, and those security providers conform to a certain interface which we call the Java cryptography extensions. And the modus operandi is something like this. We have the application which makes a request for a message digest.get instance, SHA-256, and then the cryptography architecture is going to have a list of providers chained together, and it's going to search for the first provider which can provide an implementation of SHA-256. So in this case, provider A does not, but provider B does have an implementation of SHA-256. So that implementation is going to be returned to the application. And the Java security file, which I spoke about, the default Java security file looks something like that. That's from OpenJDK version 17. So you see there are different providers and their priorities. The one important point here is that none of them are FIPS certified by default. So OpenJDK does not include any FIPS certified provider. Yeah, this is again an extension of the previous slide. We can just say cipher.get instance and say I want an AES instance which uses the CBC mode and the PKCS5 padding, and if that is available with the provider, that will be returned. Now coming to FIPS compliance of Java applications. So unlike this, where if your application used what we call the native FIPS certified modules directly, it would be FIPS compliant. Here you have an additional layer to take care of, because now your applications are running inside a Java runtime. And that means for the application to be FIPS compliant, we should make sure that the Java runtime is also FIPS compliant. So a FIPS compliant application needs a FIPS compliant Java runtime, which in the Java cryptography architecture context means it needs a FIPS certified Java security provider. So I just want to make sure there are no questions on this, because this is going to be a significant milestone in the timeline of the stock. Okay. So now what is the problem with Java? So as I mentioned, OpenJDK does not include a FIPS certified provider or a FIPS compliant provider. So as a result, the commercial distributions of JDK, I don't know whether it's as a result, or I don't know whether the first point is a cause of the second point or the second point is the cause of the first point. That's debatable. But commercial JDK distributions have their own FIPS solutions. And that space is quite fragmented. So that's what I'm going to talk about next. So before that, some basic points about what a Java security provider can be. So it can be a Java-only source. For example, there is something called Bouncy Castle, which has a FIPS certified module. If you have a Java-only security provider, it needs FIPS certification. In the case of Bouncy Castle, we do have a FIPS certified Bouncy Castle available. The other is what we call a pass-through provider, which means it's just a Java wrapper around a C or C++ native module like OpenSSL or NSS. In that case, because it's just using the services of that native module, there is no specific certification required. If the wrapped module is certified, then we say the wrapper module is compliant. It doesn't need certification. So these are the two kinds of security providers which we can have, Java only and pass-through. Now what does a FIPS certified or a compliant provider do? So on the left side, you see it's asking for AES CBC PKCS5 padding, which is a FIPS approved algorithm So a FIPS compliant security provider will return a cipher instance, a cipher object for the application to use. Whereas on the right hand side, you see the mode is EAX, which is not FIPS approved. So in that case, the provider is going to just throw a no such algorithm exception. So this is what we expect from a Java security provider, which is FIPS compliant. Now let's talk about the fragmented Java space. So there are, as I said, there are different distributions, commercial distributions of Java, and each one has adopted its own FIPS solution. So Oracle JDK, again, this is, it's not very clear unless you are a customer or a user. You don't really know from the user guides or the documents what actually happens inside, because all these are quite closed source and proprietary. So it's apparent that in the Oracle JDK context, they have some, because these are some publicly available documents where they talk about how to enable FIPS in a Java virtual machine, and they talk about configuring two providers, which I'm not sure if they are Java only or pass-through. I'm not sure. And so that's what Oracle does. Red Hat, if you search for the FIPS enablement of the Red Hat builds of OpenJDK, a provider called Sun PKCS11 NSS FIPS, and there are other providers as well, but that's a snapshot from their website. So again, they are using, this looks like they use the Network Security Services module, which is again something native, and there are a lot of certified NSS modules on the CMVP side. So looks like maybe it's a pass-through provider, I'm not sure. But it's different from the Oracle JDK. So the latest interesting thing is what Amazon Corretto is providing. So they have a security provider called ACCP, which stands for, I think, Amazon Corretto Crypto Provider, which is based on a native library called AWS L-Crypto, which is, as they claim, an augmentation of Boring SSL, which is, I think, a downstream of OpenSSL. So in this case, AWS L-Crypto is seeking FIPS certification. I don't know whether it's, their GitHub README says they are still waiting for FIPS certification. But my understanding is once AWS L-Crypto is FIPS certified, ACCP becomes a FIPS compliant Java security provider. So that's what Amazon Corretto is providing. If you look at Zulu, which is another Java distribution, they say that they don't call themselves FIPS compliant, and they recommend the use of Bouncy Castle, which is, I should say, a third-party FIPS provider, which has, a third-party FIPS certified security provider. And they make an interesting statement down there, which is, they say Azul may consider providing direct Bouncy Castle support in the future. So in short, most of the commercial JDK distributions are providing their own FIPS solutions. Again, because there is scope for strong commercial activity here, it may be justified, but that brings down the, I would say, chances to collaborate and grow together. That may be an impediment, but that's just my opinion. So what are we at Canonical doing right now about this? So we have a few things which are work in progress. So we are also working on a FIPS compliant OpenJDK 11 for Ubuntu, which uses the Bouncy Castle FIPS provider. We are also doing something, this is again experimentation. We're trying to prototype a pass-through provider which uses OpenSSL. But again, this is the second one is in quite an experimental stage. the more important thing that we are doing is we are asking questions. So the question is, so if we want to have Java security, a FIPS enabled, a FIPS compliant Java security provider like that, which is just a Java wrapper around OpenSSL, and it uses FIPS certified OpenSSL. If we want to have something like that, open sourced, what can be done? So my understanding of the OpenSSL model is that FIPS supporting code is present upstream in OpenSSL. If you open the OpenSSL project, you will find instructions to build OpenSSL in the FIPS mode. And then FIPS certified binaries are license builds. So an organization will take that FIPS certified, that upstream code, maybe package it, and build it in the FIPS mode, and those builds are licensed, and those builds are which are submitted for FIPS certification. Now the question is, can we come close to this model in Java? And so when we talk of upstream, now we'll start talking about the OpenJDK project here. And OpenJDK is unlikely to support this cause for their own reasons. I'm not against that. But in the absence of upstream support for FIPS supporting source code, the larger question is where or what could be a good home for the sources of such a provider. So that is the question that I want you to think about, and I'm not saying anything, this is an open question. I'm not saying it should be here or be there, but that's what we are trying to figure out. So if you have any questions, thoughts, opinions, do let me know. If you want to discuss now, we can do that. Otherwise, you can get in touch with me anytime later.
Hey, thank you very much for your insights. One thing I was wondering, you talked about OpenJDK and how it could be packaged with the FIPS support, and I was wondering how the integration will happen. Will there be like two OpenJDK packages, two variants like OpenJDK and OpenJDK FIPS, and then we can install one of the alternatives? Or will it be like one package that is like configured at runtime?
Yeah, so I think it will be so in the context of OpenJDK, the FIPS supporting provider will sit as a part of the OpenJDK project in the OpenJDK branches, and there will be support in the build scripts to build that provider, just like OpenSSL has. So if someone wants to build a FIPS compliant provider, they can do that just by tweaking some of the build parameters. But I think the challenge is OpenJDK is very unlikely to support anything like that.
Any more questions? No.
Okay.
All right, then I guess this is the end of the talk. Thanks a lot, Pushkar. Great stuff from one Java fan to another one. So, cool.
Thank you. Thanks for coming.